Good morning, students. Last class we have seen what is Lami's theorem and triangle of vectors we have seen, and before that we should learn what is equilibrium, and after the equilibrium concept you go to after the equilibrium concept you please go to Lami's theorem, and after that you go for the tangent line. So now I would like to teach equilibrium and the points related to the equilibrium. Okay, so now what is equilibrium? We can see now, students. So now see, when a number of forces acts on a particle, so equilibrium we are discussing. So definition of equilibrium, you see, a number of forces acts on a particle. Number of forces acts on a particle and keeps the particle at rest. So number of forces acts on a particle and keeps the particle at rest, then the particle is said to be in equilibrium. So in that situation we say that the particle is said to be in equilibrium. Okay, students, equilibrium means the resultant force on it must be zero. Okay, students, see, equilibrium means resultant force on it must be zero also. So equilibrium means resultant force on it, must be zero. Then we say that the object is said to be in equilibrium when number of forces. See, students, this is the particle I am taking. Some number of forces are acting on the particle. So this is the particle, and these are the number of forces acting on the particle. Like some different number of forces are acting, and the resultant force on it is equal to zero. That is, F net must be is equal to zero. So F net is equal to zero. So that implies, so A net is equal to zero. That situation, net acceleration is also equal to zero. So see, students, when a number of forces acts on a point and produces zero acceleration, so obviously whenever the net force is zero, net acceleration is zero, the particle is said to be at in equilibrium position. So that what is equilibrium we have seen now. And now next point, the first point we have seen about equilibrium, students. Next, the second point is and the second point is a single force cannot keep a particle at rest. And see that single force does not exist in the universe. Forces, minimum two forces or more than two forces, or some number of forces will act on a particle and if the total sum of all the forces is equal to 0, then the object may be at rest or may move with uniform velocity. So it may be at rest or may move with the uniform velocity. But single force will never keep the particle at rest. Single force. For example, see, this is the duster. I hold it in my hand like this. See students, so my hand is exerting some force on the duster in the vertically upward direction. Its weight is acting in the downward direction. Okay students, so weight is acting downward. So here the number of forces acting on it too. Not only the force exerted by my hand is not only the force which is keeping the object at rest, because gravitational pull is acting vertically downward. So normal force exerted by my hand is upward direction, and even if you consider the air forces, they will exert some force on this, and air from this side exerts the force on it. Air from this side also exerts the force, this side and this side. Because of that also we will have the forces, and if you consider all those forces also, the net forces must be 0, then only object will be at rest. Otherwise, if the downward pull is more, the body keeps on going. If it is a huge mass, then I am unable to apply the force, then downward force is more, it will fall down. So remember students, single force can never keep the particle at rest. And next one is minimum number of forces, minimum number of coplanar forces required to keep a particle at rest. Minimum number of coplanar forces. So third point I am telling. So third point, what is that you see students? So minimum number of coplanar forces. Minimum number of coplanar forces. So minimum number of coplanar forces required. Forces so required to keep a particle at rest. To keep a particle at rest or 2. Okay students, so this is one important point you see. So minimum number of coplanar forces required to keep a particle at rest are 2. So those are, this is the dot and this is one force and this is another force. So if these two forces are equal in magnitude, opposite in directions, then the particle will be at rest, and these forces are lying in the same plane only. It means if this is one force and this is the another force, so balancing each other, so the object will be at rest. Otherwise, this is one force and this is, so this is another force, okay, which are equal in magnitude, opposite in directions, and should lie in the same plane only. So they are lying in the same plane only. If I take like this, okay, up like this, the forces will come. If I take like this, the forces will come. Okay, students, and they should be equal in magnitude, opposite in directions you should get. So the minimum number of coplanar equal forces required to keep a particle at rest are 2. And next one is, and next point, minimum number of unequal coplanar forces. Unequal coplanar forces required to keep a particle at rest are 3. So this is a particle. This is a particle. Okay, students. So this is a particle. This is one force. This is one force. This is another force. And this is a third force. Okay, students. So this is F1. This is F2. And this is what you know, students, F3. So like this we have 3 forces. Okay. So which are lying in the same plane only. So all these forces lies in the same plane. They are lying in the same plane only. So 3 forces are there. which all are lying in the same plane. Okay, the magnitude of these two forces magnitude, so is balanced by this one, or the resultant of these two forces is balanced by this one. So the minimum number of unequal coplanar forces required to keep a particle at rest are 3. And the next one is the minimum number of non-coplanar forces. Minimum number of non-coplanar forces required to keep a particle at rest are 4. Non-coplanar means which do not lie in the same plane. So that is about the fourth point. Okay, and next one is, so next one we are going to discuss what is equilibrium. So next one is, what is equilibrium? So what is equilibrium? Okay students, if a single force balances the set of forces acting on a particle. See, so this is a particle, and this is one force, first force, second force, third force. So this is F1, F2 and F3. So these are the three forces. These three forces, a single force, for example, one single force, greater magnitude of force is there. Let this force be F. Okay, a single force balances the set of forces which acts on the same particle. Then this single force is called equilibrium force. This single force is called equilibrium force. This single force is called equilibrium force. Okay students, the single force we name it as equilibrium force, and the resultant of all these forces. Okay, and the equilibrium force, if I denote the letter F, the resultant of these three forces F1 plus F2 plus F3, that is called the resultant force R. So resultant force R, this resultant force R is equal to, so sum of other forces, so F1 plus F2 plus F3. So the equilibrium force is equal in magnitude. The equilibrium force magnitude is same as that of the resultant force magnitude, but opposite in directions. When some set of forces are acting on the particle, the resultant of all these forces, I am denoting the letter R. This R direction is opposite to the direction of the F bar, means what? Which is opposite to the equilibrium force. So what is equilibrium we have seen, and equilibrium force is equal in magnitude, opposite direction to this resultant force we have seen. So, and the next point is, so next point is, when a number of coplanar forces acts on a particle. So for example, n number of coplanar forces are acting. So n number of coplanar forces acts on a particle and keeps the particle at rest. When n number of coplanar forces acts on a particle, so n number of coplanar forces acts on a particle and keeps the particle at rest. Okay students, then the vector sum of all the forces, in the x direction, sigma fx is equal to 0, sigma fx is equal to 0 and sigma fy is equal to 0. Okay students, so when a number of forces acts on a particle, the algebraic sum of the forces of the components in the x direction must be 0 and algebraic sum of the components of forces in the y direction is 0 if the object is in equilibrium. Okay students, and next point is some n number of forces are acting on a particle and the particle is not at rest. Some n number of forces are acting on the particle and the particle is not at rest. Then the resultant force of that can be written as F bar is equal to Fx into I cap plus Fy into J cap. So this F bar equal to Fx into I cap plus Fy into J cap. So its magnitude F is equal to, so what to write, Fx square plus what to write students, Fy square under root. So this F is equal to root over Fx square plus Fy square will write, and Fx is equal to component of all the forces we should write. Then Fx is equal to component of all the forces F1x plus F2x plus F3x plus so on plus Fnx, and similarly Fy is equal to what will you write students, F1y plus F1y plus F2y plus F3y plus so on plus Fny. Like this you are writing all the forces. This is called Fx and this is called Fy. Okay students, so that Fx and Fy you are getting, and you know how to calculate the magnitude. So okay students, you know how to calculate the magnitude. So I coefficient square plus j coefficient square. So like this we will write. Okay, now we go for and we already have discussed about what is that, Lami's theorem. So if so Lami's theorem, if three forces acts on a particle and keeps the particle at rest. If three forces acts on a particle and keeps the particle at rest. Now this is a particle. This is one force. This is another force. And this is the third force. Okay students, the first force is F1, second force is F2 and the third force is F3. Like three forces. The first force I am representing with the letter A bar, and this is with the letter B bar, and this is with the letter C bar. And if I write the vector sum of all the forces, I will get 0. A bar plus B bar. If three forces act at a point on the particle and keeps the particle in equilibrium, then A bar plus B bar plus C bar must be is equal to, so 0 we have to write. Okay students, and now I want to discuss some problems based on the Lami's theorem, based on the equilibrium and Lami's theorem we can discuss. Now see students, so problem number 97 in the mains level. So mains level, So mains level. So I'm taking the problem number 97. So three forces F1, F2, F3 act simultaneously on a particle. So three forces he has given. Three forces act simultaneously on a particle, and if the particle is in equilibrium and the particle is in equilibrium, he is telling means the set of all the forces must be equal to 0. So find the value of A. So see students, he has given three forces, and these three forces are acting on the particle, and sum of all the forces is equal to 0, he is telling. Because it is in equilibrium, he is telling find the value of A. Then the net force. Okay, see students, so he has given three forces. First force F1 is equal to, so first force F1 is equal to A into I cap plus J cap plus K cap, and the second force F2 is equal to 2I cap minus 3J cap plus 4K cap, and the next one is F3, third force, that is what is given 8I cap minus 7J cap plus 6K cap. These are the three forces acting on a particle and keeps the particle at rest. So three forces acts on a particle. So these are the three forces acting on a particle and keeping the particle at rest. So particle is in equilibrium. So the net force I should write is equal to 0. Then F net. So then what should I write students? F net is equal to, so what I can write, F1 bar plus F2 bar plus F3 bar is equal to 0 I have to write. So that is what F net. So F net is equal to, so sum of all the forces must be is equal to 0. Okay students, so I'll add all these forces. So F net must be is equal to 0. F net is equal to 0 since the particle is in equilibrium. Since the particle is in equilibrium, so F net must be is equal to 0. So now you write students, what you write, add all these forces. So I cap coefficient in the first one. So I cap I am taking common here. So what is the A you have here? I cap you take it common, 2 is left here. I cap take it common, 8 is left here. So fine, since you are adding all this, and similarly plus J cap I am taking common. So here we have given minus, okay, plus J cap. If you take J cap is common, minus 1 is left. Here J cap is common, minus 3 is left. J cap is common, minus 7 is left. Plus K cap take it common. K cap take it common. What will be left students? 1 plus K cap take it common 4 and K cap take it common 6. Okay, that is equal to 0. Okay students, since F net is equal to 0, and this 0 we will write it as 0 into I cap plus 0 into J cap plus 0 into K cap. Okay students, we will write like that. Now see students, equating I cap coefficients on either side. So here I cap coefficient is A plus 2 plus 8, and here I cap coefficient is 0. Then A plus 10 is equal to 0. Then A is equal to minus 10, and J cap coefficient. So here if you take J cap common, what is left? Minus A is left. Okay students, J cap if common minus a and k cap is common a into 1. So here a is left. Okay. So okay students, see. So then j cap quotient and j cap quotient. Here j cap quotient is minus a minus 10 is equal to 0. Then a is equal to minus 10 units. A is equal to minus 10 units. And here k cap coefficient. So k cap coefficient is a plus 4 plus 6. And here k cap coefficient is 0. Then a plus 10 is equal to 0. Then a is equal to minus 10. So he asked to find the value of a only, and we have found the value of a. So this is a problem based on equilibrium. So three forces acts on a particle and keeps the particle in equilibrium. So means the net force must be 0. The net force means sum of all the forces, you have to make it equal to 0. So we got the answer. And see another problem, students. See another problem. So that is 98. So what is the 98 problem? You see, three vectors acts at a point O as shown in the figure and keeps the particle in equilibrium. Then find the value of theta and p they are asking. So okay students, three vectors acts at a point. So find, this is a point, this is a point. So this is one force, 10 newtons. This is another force, it is also 10 newtons. And this is some force, P, it is making an angle theta. So this is (10√2) they has given. Okay students. So the magnitude of this force is given 10√2. Now we should write the components of 10√2. We should write its components. So then 10√2 and this angle it has given 45 degrees. So its component in this direction is, this is 45. So means its component is 10√2 cos 45 degrees, and here its component is 10√2 sin 45 degrees. Okay students. Then 10√2 into sin 45, how much you have to write? 1/√2. So then √2 gets cancelled. You will get this value is 10 newtons. This value is 10 newtons. This is 10√2 cos 45. 10√2 into cos 45 is this value 1/√2. √2 gets cancelled. This is again 10 newtons. This is also 10 newtons. And the question mark here is we have to find what is P and what is theta. Okay students, so some forces are acting at this point O, at this point O, and keeps the particle at rest. Okay, then find the number of find theta and find P, that is a question mark. Okay, and this is the P, it is making theta, so its component this side is P cos theta, and its component this side is P sin theta. So then already 10 newtons is there, and its component this side you have written. So its component this side is 10√2 cos 45, that is 10. 10 plus 10, 20. So P sin theta is equal to 20. P into sin theta is equal to, how much you will get? 20 newtons. Okay students. And next one you see students, p cos theta plus 10 is equal to 10. So means I am equating the forces. So you see here students, p cos theta plus 10 is equal to 10. So p cos theta plus 10 newtons is equal to 10. So we are equating the forces along y direction. Okay students. So this 10 plus p cos theta is equal to 10. So 10 gets cancelled. Then what will you get students? P cos theta is equal to 0. Then cos theta is equal to 0 means theta is equal to 90 degrees. So this value we got it. So as you got theta 90, we substitute that 90 here. Then P into sin 90 degrees value is equal to 20 newtons. P into sin 90 value, P into 1 is equal to 20. Then P is equal to 20 newtons. So this is the value of P. Okay students. So P value you got 20 newtons there, and theta value you got 90 degrees here. Okay students. So this is the problem based on equilibrium only. And we can see another problem. So based on equilibrium. So next one is 11 forces each equal to 5 newtons. So problem number 96. 11 forces are there. 11 forces are there. 11 forces are there. So each force value is equal to each force value is equal to 5 newtons. Each force value is equal to 5 newtons. If the particle, okay, each force makes an angle theta is equal to 30 degrees. Each force makes an angle theta is equal to 30 degrees with the next one. The resultant of all the forces is asking. So now see this problem students. 11 forces are there. Each force value is equal to 5 Newton, and each force makes an angle 30 degrees with the next one. So each force makes an angle of 30 degrees with the successive force. Okay students. Okay. So then the question mark is the resultant of all the forces asking. So question mark is resultant of all the forces. Resultant of all the forces we have to find. Then find the resultant of all the forces. That is the question mark. So we need to calculate the resultant of all the forces. Okay. So fine. So for its solution, if n number of forces acting on a particle, if n number of forces acting on a particle and each force magnitude is equal to P and keeps the particle at rest, n number of forces acts on a particle, n number of forces acts on a particle and each force magnitude is equal to, what is that, P, and keeps the particle at rest, then the angle between any two forces must be is equal to 360 degrees by theta. Then the resultant force we will get 0. Okay. And see students here, for its solution, if n minus 1 number of forces, if n minus 1 number of forces, if n minus 1 number of forces, if n minus 1 number of forces acts on a particle, acts on a particle, if n minus 1 number of forces acts on a particle, and each magnitude is equal to p, and each magnitude each magnitude is p, so each force magnitude is equal to p. Okay students, n minus 1 number of forces acts on a particle and each magnitude is equal to p, and angle between n minus 1 number of forces and angle between n minus 1 number of forces is, so 360 degrees by, and the angle between n minus 1 number of forces is 360 degrees by theta, angle between n minus 1 number of forces n minus 1 number of forces acts on a particle and each magnitude is equal to p, and angle between any two successive forces, and the angle between any two successive forces is theta. Angle between any two successive forces is equal to theta. Any two successive forces we have, it is given theta. So and then that and 360 degrees by, and this 360 degrees by number of sides you write it students, so n, then 360 degrees by 360 degrees by if you write theta, but theta it has given 30 degrees, so you will get 12 we got it, but it has given 11 only, so then what is the angle he has given between any two forces? You take that theta is 30 degrees. So then angle between any two successive forces is theta. Then you check it, 360 degrees by theta is equal to 12 you are getting. But he has given only 11 forces. So the resultant of all the forces is equal to, so resultant of all the forces, so the resultant of all the forces is equal to single force P only, is equal to single force P. So the resultant of all the forces is equal to the single force P. Okay students, next class we can see the remaining problems. to teach still more better. I'll try to improve my levels well. So please follow the class update every day and keep solving the numerical